Hey, welcome back to converting repeating decimals to fractions and proving that they are what they are, part 2. So in our last video, Mr. D hit a home run. That guy was very menacing. And for this one, sorry, there's not going to be any fun in the middle, but we just need to get through a couple more examples on how to do this well. So you should have in your workbook on page 4, these 3 examples already filled out because that was the video from Tuesday. And then this one, it says try on your own. So let's go ahead and take a look at what you should be able to accomplish knowing what you know now. N equals is step 1. You want to set up a condition where we have an equation because that's how we can prove things to be true by using the transitive property. So if the variable is equal to a decimal and the variable is equal to a fraction, the decimal equals the fraction. Step 2 is to multiply by 10 or 100 or 1,000 depending on the place value of the last digit of repetition. So in this case, the 9 right here is in the hundreds place. So since that's in the hundreds place, you want to multiply by 100 to both sides. Tomorrow, I'll tell you a fun story about multiplying things to both sides and breaking stuff. Okay, so this would be times 100, which moves the decimal 2 to the right. So it'd be 509.09. Don't forget that there's a bunch of 09s here. Okay, this is 09 repeating forever. So just write a bunch of them out so you have something to cross out on the next step, which is step 3. In step 3, I want you to subtract the value of n from both sides. So over here, you're subtracting 1n. And then from this side, you're subtracting the value of n because n, we said, is equal to the decimal. So it's totally legit to just like subtract the number on this side because n and that number have equal value because we said so in step 1. So subtract it from both sides. Draw a line and then do the subtraction. So we got 99n. And over here, you want to wipe out the repeating decimal because when you subtract something from itself, it's gone. But don't forget to subtract what's left, which is the 509 minus 5. Bring down your equal sign, and it's equal to 504. Okay. Step 4, you want to divide both sides by the coefficient of n, in this case, a 99. Now that doesn't magically disappear. 99 divided by itself is 1. So what you said now is 1n, or n, right? 1n is equal to 504 divided by 99. Now, if you change that into a mixed number, 99 goes into 504 5 times, and you multiply 5 times 99, and you get 495, and you subtract that from 504, remainder 9 over the denominator. And then step 5, after you divide those two and probably change it to a mixed number so you get a good look at it, you always want to simplify if possible. So we can. So n equals, well, if you divide both of these by 9, clearly, that would be 5 and 1/11. Okay. Now, I said at the beginning, if n equals a decimal and n equals a fraction, the decimal has to be equal to the fraction. Okay, that's how it works. So you have proven beyond a shadow of a doubt that those two are in fact the same. So the repeating decimal is a fraction, which means it's rational. So all repeating decimals are rational because they can all be proven this way. Okay. So at this point, you're probably like, I like it, but it's kind of boring. To which I would say, yeah, you're right about that. Cool. Now, one more thing I want to look at, just for the sake of argument, is the idea of 0.9 repeating. Because in our notes, we wrote down that 1/9 is 0.1 repeating, and 2/9 is 0.2, and so on. So if you follow that logic, I said in class that 9/9 would have to be 0.9 repeating because it's divided by 9, and that always creates single digit repetition. But wait a minute, 9 over 9 is equal to 1. So how in the world does that work? Okay, well, let's take a look at it. If you say n equals 0.9 repeating and use the same 5 steps that we just ran through, let's see what we end up with. So multiply both sides by 10. Hope you're writing this down. You can just do it right over here too, that's fine, you got plenty of space. Subtract the value of n. 10 minus 1 is 9. So 9n equals, well, go ahead and cancel over here the repeating 9s. Don't forget to subtract what's left, which is 9 minus 0. So 9n equals 9. And then you want to divide both sides by 9. And you end up with n equals 1. Yeah. If n equals 1 and n equals 0.9 repeating, by the same logic that we proved that the repeating decimal is a fraction, we've just proven that 0.9 repeating is equal to 1 through the transitive property. Okay. Transitive property is something you want to know about. Transitive property. So yeah, okay. I showed this to one of my friends and it's like, yeah, I still don't buy it. Because how can 0.9 repeating? What are you rounding at that point? It's like, no, I'm not rounding. It's the proof, man. It's the proof. The proof's in the pudding right there. Okay. So yeah, I don't know. Don't forget to do your work. Desmos, IXL, 10 minutes. Quality, not quantity. Play the Kahoot, because why not?